I want to talk about, sort of following on from Roger, this notion of a variable and changing climate. Just want to quickly give credit to some of these projects that we're involved with. One's DAF, Australia's Farming Future, and Daniel Rodriguez is involved in that project. And one of those exercises we're trying to do that Roger mentioned of trying to take some of the global circulation model and run it through things like APSIM. We're also funded with some heat stress work on the Managing Climate Variability program. And also I'm involved with the Primary Industries Adaptation Research Network, which is trying to get, I guess, people involved with adaptation together. So I'd be keen to hear from anybody with that. I want to talk about climate variability and climate change. So this is a simple graphic that Roger Jones produced. Basically, we see that we have obviously a variable climate, goes up and down. We have a coping range, and where things get too hot. This is actually northern Victorian rainfall until recently, and that sort of decline. What I guess I'd be interested in, so this sort of there's obviously has been a lot of discussion on climate change and so on. So I'm going to do an exercise where I'm going to, this is a sort of a vote you can take. Voting is non-compulsory, you don't have to do it, but I'm going to count from 1 to 10, and I'm going to use 5 as saying that the attention on climate change is about right now. 1 means that climate change is a bit of a scam by people like me to get funding, and 10 means we're not putting enough effort into climate change. Does the question make sense? So I'm going to count from 1 to 10, and just put up your hand where you think you are on that spectrum. Again, you don't have to, it's non-compulsory. So I'll just count from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I've noticed some people extremes there. In any case, in a room like this of learned people, there's a variety of opinions. Some of you are wrong. I guess that the temptation, and I've been advised by a lot of people to say, don't talk about climate change, talk about climate variability, and talk about short-term weather events and extreme weather events. And I accept that the main way forward as we deal in agriculture is by focusing on how we better manage weather events, how we get on top of year-to-year climate variability. That is going to be the most effective way for us to prepare for future climate change. But it does not help us, I believe, to say, let's just talk about variability and ignore the huge wealth of science that is saying we are changing the atmosphere, and that is changing the global climate, which will change local climate. So this is a simple graphic. It's sort of, Roger talked about the different scales, and there's different scales in time and space in terms of the sort of up here, what's happening over centuries and decades, down to individual events and so on. And so we're sort of working up and down this sort of scale. And I want to come back to that. There's different decisions and so on. But I think that an important point is that heat events and so on that happen down here are influenced by what's happening up here. It is naive to assume that we can change the global energy balance and not change what's happening in a local area. As the late Stephen Schneider said, when he was talking to South Australian farmers, we know most about the global energy balance and we know least about rainfall on your farm. Obviously, it'd be best if we hold a lot of information locally, but there's least about how that will change. So, very simply, temperatures are rising. This is a graph where this is Bill Leake, who fell off. He's the cartoonist for The Australian. He fell off his balcony, and in late 2008 and 2009. This is the first cartoon he wrote when he came back to work, and he's sort of saying all these strange things are happening. Hard times ahead. Spend. Gitmo convicts bound for Botany Bay and so on. Aussie cricket is a joke. He then also had this one, 2008, the coldest year this century, and as if this was something really strange. There's only been 8 years that century, one of them has to be the coldest. The only way that that cartoon makes sense is if we're saying every year has to be hotter than the one before. If we say there's no variability, we just have to be a continual step. And unfortunately, the media will present things that way. We will have warm years, we will have cool years. What we're saying is we'll get more warm years than cool years. And I think importantly, in a graphic like this from the Bureau of Meteorology, we overemphasise the individual hot years. The important thing is the decadal means. Every decade is getting warmer, and what's happening at a decadal level is much more significant. Now, Roger and I know the people in the Bureau who get behind this sort of data. They are not Greenpeace activists. They're nerds with lots of biros in their pockets with an incredibly anal view of keeping data together and so on. So this sort of data is not just a sort of a sense of someone making this up or sticking thermometers in the middle of cities. This is clear data that things are warming. If you're saying that the same evidence for drying is just not there. So we have the strong evidence for warming, the story on rainfall is much less clear. An important point, and I want to come back to this, is that as you would expect, if you just move a normal distribution, what happens in extremes is quite dramatic. And as moving to South Australia, these heat waves and these extremes, the impact of those on agriculture and on human life are incredible. Blair Trewin, who works in the Bureau, will say that yes, we get cool events and warm events, we're just getting double the number of warm than cool in terms of records and so on. So things are warming. I want to make it clear that, and I'm not going to dwell on this long, but I want to make it clear that climate change is not just caused by human factors. It's caused by ocean circulation, volcanic eruption, solar variation, orbital variation, greenhouse gases, and then there are feedbacks and so on. A false argument is put up by some people to say this is all human or all natural, as if we can have one or the other. We know that climate change 101 is that there's all these factors changing things. What we're doing on top of that is we're changing the atmosphere, which is changing global climate, which will change regional climate and have impacts on local systems. Once you accept those red arrows, it's important to, however, also accept that even though we have a high degree of certainty in those red arrows, that's not to say that everything that happens is because of changing our human influence on the atmosphere, but we are seeing that there is a lot of uncertainty in terms of what our future emissions will be. That is, what technology and so on will happen. We force different global climate models with different emissions and you get different outcomes. Some will warm the planet more than others. The really difficult question of what does a warmer planet mean for Goondiwindi, especially rainfall at Goondiwindi, is an enormous challenge. And then what does that mean for impact? What does that mean on wheat growth and farming systems? A point I want to make here is that there's a whole role for human intervention in terms of emission scenarios, in terms of working towards a lower carbon future, and agriculture will be impacted by that and will be asked increasingly to play a role in that, both as reducing its contributions and as a sink for carbon. However, important to this sort of meeting is the fact that what happens in the future by 2030 or 2020 is not predefined. What happens between changes to global climate and impacts on Goondiwindi is a scientific question. There's an answer to that. We have scientific uncertainty on that. We don't know the answer, but we're not going to influence it. The question on how climate change will be manifest here. But there's an enormous influence of people in this room to say, what will that influence be in terms of preparing? And I guess what I would see is let's make sure we do get work better on seasonal forecasts, the sort of things covered here and so on as well. However, to my mind, to not acknowledge that we are seeing a warming and to be watching out for some possible changes in drying is an important thing to do. So a simple way of looking at this is you can have this argument with a kid on the beach as to what destroyed the sandcastle. Was it the wave or the tide? And you can go backwards and forwards and say it was either the wave or the tide. And we know it's actually the wave that does do the damage to destroy a sandcastle. I use this a lot, and often farmers will come up to me and say, oh, I'm a bit of a wave man myself. And I guess what I'd say is you don't have the choice. Waves and tides happen together, and so we are seeing tide in terms of temperature, and waves on top of that. In terms of rainfall, in this part of the world, there's just a lot of decadal variability and a heck of a lot of year-to-year variability. It's very, very hard to make any strong statements about what's happening in the tide in this part of the world. Although, as you move to Western Australia, there is some drying, and certainly in Southern Australia, there's a much more worrying aspect about those projections. However, I would still say in Southern Australia that the precipitation outlook is the most worrying, but also the most uncertain. I'd also say here that it has to be worrying, but even more uncertain, because there's a disagreement between the models and so on. However, in terms of this drought that was leading up to 2008 and so on, you can see that area in Southern Australia that I've moved to, also north of here, was also pretty hardly impacted by the same sort of period. This is not an argument about climate change, it's just saying that there was that extensive drought. During that time, these are on Eyre Peninsula, on farms there, and this is a group working there asking this question: is this drought or aridity, drought or drying, variability or change, cycle or shift? Now, some people will say it doesn't matter. It doesn't matter what's happening, it's just been dry for a while. But if you talk to, I guess, people in that community, they'll say, if you're saying where somebody's leaving, we just had one too many droughts and we're just out of here, we're a bit sick of it, that's one message. If someone says, I'm leaving because the climate's changing, because this area is becoming more arid, we've got this great big desert to the north of us and it's heading south, that's a completely different message to people left behind. So this question about are we seeing increased aridity or is it just dry? Now that one way to sort of think about this is to say, I'd hasten to add, we don't know the answer to that. But certainly in Southern Australia, there's a strong sense of deciles. So people will talk about it being a decile 3 season, a decile 7 season, and that's useful. Deciles, it's the language of risk. So if someone says it's decile 7, they're saying 7 years out of 10 it's been drier than this, and 3 years out of 10 it's been wetter. And so you know what you're saying with that. So with a bit of recreational spreadsheeting, you can go back to the record and sort of colour in the wet years and the dry years with the different colours and so on. So blue is the decile 10, and you can see there for this low rainfall environment, they had a shocking run of years and there's not much rain there, sort of thing. However, the last 2 years were fantastic there. So there were people telling them from Adelaide and from Canberra, just get out. I mean, this is obvious, it's all over because the projections are saying it's dry. Then we had 2 fantastic years. So on rainfall, we have to be very careful about being too simplistic about drying. One way to sort of look at this, and I've found that most things in life can be explained with a pie chart. One way to look at this is to say that, is to take those deciles and colour them and say that there's an equal chance of being in the bottom third of years or the top third of years. So there's the, if we have an equal chance of you saying being the bottom 30 years or top 30 years. Now, in terms of what climate science says is we may get a 5, 10 or 15% decline. For this part of the world, it's about a 5% decline. This is for Southern Australia, or 5 to 10% decline. What that means is that we change the pattern on the wheel. This does not mean we get no more good years. It just means we get an increased chance of dry years. Interestingly, when we talk to the group of consultants in that environment, you say 15% decline in rainfall, and they say, well, me and most of my clients could do 15% better. We could sort of tweak things by that, especially in terms of, and so on. However, if you then say that what 15% decline in rainfall means is a chance of being in the bottom third of years goes from 30% to almost 50%. So it's saying every time you sow a crop, you have an equal chance of being in deciles 1, 2 or 3 or higher. Suddenly the sort of sense of, well, that could be pretty hard to handle. Obviously, when you get those very dry years, you're in a situation where you care a lot about the prices you're getting and you care a lot about the timing of that rainfall. The other interesting point about this is that the young growers say, okay, we might accept those sort of potential changes. What we're really worried about is how well we can capture these good years when they come along and how the grain handling and everything else will handle those. And last year was a good year and the grain handling was very difficult. So here's Goondiwindi. It's a summer rainfall and there's winter rainfall. So I guess in terms of Goondiwindi, if I'm right by looking at this, and the pink is the 5-year moving average, it's been a reasonably run of dry winters, whereas last winter was better. Does that sound roughly right? And we can do the same exercise with summer rainfall. Again, those incredible peaks, and there's winter rainfall. There's the dramatic 1998 that Roger spoke about, the La Nina in 1998. And then this run of very, very dry seasons, and then last year a better season, although often a lot of that rain came at the wrong time. And we're going to do a similar thing. Colours aren't showing up quite as well there. I guess an interesting point is that the actual change in the odds are not as great here as they are for Minnepa, and that's because the background variability is much higher here. If your background variability is very high, a 5% or a 10% change in the mean doesn't have as big an effect as you than if your background variability is much less. If you go to the very safe areas of South Australia, which have hardly any variability, a small change will do a lot of things to their deciles. So that's, I guess, because the background year-to-year variability is high here, and you have the buffering of the good soils. Again, I wanted to stress this point that as we move up and down that sort of, in terms of seasonal down to extreme events and so on, the number of extreme events will increase dramatically, even if you just move the mean and don't change the variance. And there's some suggestion that we are changing the variance and doing things to these sort of events. So there's, for the November 2009, this season, these events up here had a huge impact on the South Australian and Victorian wheat crop. Note these very, very warm night temperatures, and some of the research is saying that night temperatures are just as important as day temperatures. So this was a season that was going pretty well and things were looking pretty good, and then bang, these heat events come along. We understand what's happening and why they're there. The big question is how they would change into the future. We're doing a bit of work torturing heat plants in a small chamber with a Kmart heater. But one day of heating it up to about 35 degrees was giving about a 10 to 20% yield loss. So these single days can be quite dramatic. So I guess I wanted to sort of finish up with this discussion about how much this is a Mark Howden slide, how much we're staying in this sort of, we do these adjustment changes on varieties, planting times, stubble management, water, and so on. The sort of things that GRDC Updates and the group of man of wisdom in a room like this is incredibly good at doing, and in terms of improving things and working in that sort of level. Then at what point do we make these more transformational changes? And I guess in the climate change adaptation area, this is the big discussion. At what point, how much should we be adjusting what we've got now, and at what point should we make more dramatic sort of changes? My argument is that that's much easier to do in viticulture or something like that, which is a more temperature-dependent system, given the uncertainty for precipitation that's inherently difficult to do in this sort of environment. And so this is something I've sort of put together very simply in terms of South Australian, because I do worry, although I started this by saying I think we've really got to accept climate change, I do worry that there's this naive take on climate change that agriculture is going to be just rolling over very, very quickly. I guess my frustration is that we tend to have these two extreme views. One is we're Australian agriculture and we're bulletproof, we can handle anything, and the other is Australian agriculture is going to sort of keel over with the first little bit of change in climate. And I think obviously, like any of those two extreme views, the truth is going to lie somewhere in between. So what you can do is say, do you plan for a major step change in rainfall? So we would be going through something quite dramatic, or do you plan with assumption that variability dominates the early stages of climate change? Note, this is not saying is climate change real or climate change not real. I'm saying climate change is real, but are the early stages of climate change manifest in a big change in rainfall, or are we going to sort of bounce around a fair bit? What you can then do is say, we can come back to this room in 20, 25 years' time and work out what happened. What you can sort of see, you can sort of fill this box in, and so if you plan for a major step in rainfall and it happened, it would be major upheaval but would have more orderly change, and the winners are early adopters of proactive transformational change. If we plan with the assumption that variability dominates the early stages of climate change, And that's what happens. The winners are those practicing adjustment change. So there's a lot of other things happening, transformational change to non-climatic factors. So these are agriculture's dynamic, lots of things changing and so on, but we don't let climate dominate that sort of change. To an extent, you can then also need to populate this matrix here. This is what governments worry about, is that we stick with this and this happens, failure to warn, a collapse of systems and high impact on communities. But I also worry about this one, false alarm leading to expensive and unnecessary transformational change, which would also have negative impacts on the community. So we have to sort of look at that one as well. Now, this is a bit of a false sort of sense of setting these up. We can move between those and be smart between those sort of things, but I guess it's an argument about trying to work how we can work in between those. And I'm most comfortable in the adjustment change and improving that. I just want to finish with a couple of quick graphs from the Murray-Mallee, which is incredibly dry and incredibly difficult, well, these very, very light textured soils. So there it is, there's an NDVI, there's the Murray River, and there's the crops in September 2000. There's the El Nino of 2002. As Roger shows, El Nino doesn't just affect Queensland. I spent most of my life trying to explain that El Nino does move south of Goondiwindi. And there's 2002, and there's 2006. What's interesting when you show local farmers this is they pick out these individual paddocks and individual farms, and they're the zero tillage farms that have managed through these very, very difficult times exceptionally well. And there's some extraordinary talented farmers in those areas who've coped with those sort of conditions exceptionally well. So if they can cope in those sort of El Nino droughts through zero tillage and manage those sort of systems, to my mind, there's a huge adaptive capacity into the future. So I guess I'd say there's a lot that can be done in this sort of varieties, planting times and so on. It's really important that we have the skills base. So the most worrying thing would be that we lose the sort of skills base that's in these sort of conferences and so on, and to focus it all on preparing sort of transformational change for the future. The challenge I give to you, I guess, is, and for us in this whole agronomy area, is when do these systems start fraying? When do we have to sort of realise that we've got to make some changes? So it's this question of sort of keeping a watching brief over the next decade about some of these sort of changes and trying to work out where some of those limits are and where some of those next changes may be. The other point, I guess, that people are looking at this is that some people go and make these transformational changes anyhow, quite apart from the climate aspect, and we need to learn from them in that way as well. So I'm not arguing that climate change is the only argument in town. I think it's a real mistake when that happens. We are talking about the whole variability, the weather through to climate, but I'd see that, I would be doing you a disservice if I just spoke about variability, and I would argue that you are doing your farmer client a disservice if we just talk about variability and don't mention the fact that there's underlying tide that could be changing these things in quite complex ways. Thanks.
There might be some advantages as well, and that should be from the frost in wheat point of view. Why can't, if it's getting warmer, they should be able to have wheat flowering early. That's one of the positives.
Can I just come on the frost thing? It's so GRDC through the Managing Climate Variability Program. So you're right, Vic, that if things are warmer, crops are going to flower earlier. You see that in Liverpool Plains between Corindi and the other. It's a huge time of harvest and so on. One of the worries is that whether crops will move earlier faster than frosts reduce, and certainly in southern Australia, frosts have increased with these dry springs. And so we've actually had more frosts, and there's a suggestion by Steve Crimp and others who's doing some work on this that might even be about incoming polar air and so on. So we could actually have a situation, well, let's put it this way. I think climate science is very clear that heat waves will increase faster than frosts decrease. And certainly these spring frosts are a weather event that could still whack us. And so even in emerald, where there's been such a big decline in frost, there's still the occasional late frost that comes in and hits us. As I've learnt from you over many years from Weekman Vic, you know, that frost risk is a horrible late event risk, and as Woody sort of explained to us so often, that we need to be really careful about trying to sort of predict that and forecast that, because it has such a damaging effect. So I'd see more confidence in warm temperatures, more confidence in heat waves. Of the temperature aspects, frost is the least confident because our radiation frosts are actually about clear nights, which is often to do a lot with the precipitation story. And precipitation is just worrying but uncertain.
Scientists are incredibly sceptical people. I don't actually think they cook up ideas the word sceptic. That's what they're doing.
Yeah, so I think a notion that this is cooked up by a series of people agreeing, let's all misinterpret the data this way together to get some funding. If you've hung around scientists at all, there's enough people with major personality disorders that would love to prove the rest wrong. The notion that they would all get together and agree with each other when they can't agree on anything else is just the most bizarre idea of any that I've heard. So it's or that just this complete groupthink or something. If you really did have good evidence that the underlying thesis that increasing greenhouse gases like nitrous oxide and carbon dioxide, water as a feedback and so on in the air didn't change the energy balance and so on. If you really could prove that, you wouldn't be writing letters to The Australian. You'd be writing papers in Nature, and you would be famous and wealthy beyond your dreams. So that's my basic test, that the idea that it's all just, we're suppressing somebody there who really knows it's all a hoax, is to me a very, very bizarre idea.